welcome to lesson 2 of tectonic hazards. So if you haven't done lesson 1, go back and do that one first because it will make a lot more sense if you've done that one first. And this is lesson 2, so we are moving on today. Last week we looked at the what's happening underneath the earth, the structure of the earth and all the different layers, and then today you're going to be looking at the plate boundaries, what's happening at the plate boundaries when they move towards each other, when they move away from each other, and when they move alongside each other, and what kind of hazards that can create. Follow through with the lesson. There are some links down below with resources for you and some videos that you can watch, so use those. Feel free to send me your work so I can see that you've done it, and write in the comments below any questions you've got.
Hi, so the answer to last week's lesson 1's quick quiz. What are the plates called? Hopefully you got this one is tectonic plates. Careful of the spelling on that one. What makes the plates move? It's the convection currents. Remember, they are coming up from inside the core, and as the heat comes up in the magma, you've got a crust there, and we're in the mantle. As the heat comes up, it cools. The hot magma cools, sinks back down, and then heats back up again and rises. So the whole cycle continues with these convection currents. What is the top layer of the earth which we stand on? That's the crust. Is the inner core solid or liquid, and why? It's solid. Remember, this is due to the immense pressure pushing down on the core deep inside the earth, and all that heat and pressure pushing down from the rest of the earth on top of it. And what makes heat come out from the core is the radioactive decay. We talked about this. Remember, the particles breaking down inside the core, and that generates heat as that happens. Okay, so lesson 2, what happens at plate boundaries? We're still on our topic of tectonic hazards, and today we're going to look at what's happening at each different type of plate boundary, where the tectonic plates meet, and what kind of problems and issues this is going to cause us. So what are we learning today? Hopefully we're going to know where different plate boundaries are. Then we're going to be able to describe the 4 different types of plate boundary, and we're going to be able to explain what is happening below the surface at each plate boundary and what landforms or features or hazards are expected above the ground. So as an introduction to plate tectonics, I'd like you to watch this video and make notes on rough paper. I'll put the link down below in the bio for the video. And there's 4 key questions I'd like you to listen out for. So you're just doing this on a piece of rough paper, but split your page into 4 with 4 key questions. So what are tectonic plates? What's happening inside the earth? How do the plates move? And what happens at each plate boundary? It's about a 4-minute video, and it's a BBC bite-sized one. It's really good, and this guy talks you through what's happening inside the earth. So it's good for you to watch that, make these notes, and then we'll come back and discuss it for the rest of the lesson. So go and do that now, and then come back to it. Okay, so from the video, hopefully you gathered a good background information about what's happening at the plate boundaries, and now we're going to make some notes on that in neat in your book or on a Word document. So there are 2 types of crust. So remember, we have our inner core here, our outer core, our mantle, and then the crust, which is this layer right on the outside. And our crust can be split into 2 different types of crust. We have here the continental crust, which is made up of all the land, and then we also have our oceanic crust, which is underneath the oceans, which is there. So this can be 2 different types. We can see our continental crust is much thicker, and the oceanic crust is very thin. And the oceanic crust is, if you imagine it's being pushed down by the weight of all that water on top of it, it's very dense and it's much, much thinner. Whereas our continental crust is really, really thick, and this is what makes up the land that we stand on. So we have our oceanic crust, which is found beneath the oceans and is between 5 kilometers and 10 kilometers thick. For example, most of the Pacific plate is this oceanic crust because it's right underneath the Pacific Ocean. And the continental crust is found beneath the land. It's much, much thicker, about 25 and up to 100 kilometers thick in some places underneath mountains. And an example of this one is the majority of the North American plate, which makes up the majority of North America. So the USA and Canada, if you look at that on a plate tectonics map, you will see most of that is continental crust. A lot of Russia and Europe is also on continental crust, and you'll see that on a plate tectonics map as well. So if you could write down these two definitions, pause the tape now, and then come back. Okay, so as I said, you can see this crust on tectonic plate maps. So for example, here, this area here, which I'm shading, of the Eurasian plate, all of the land there is continental crust. And then all of the area here in the water underneath the Pacific, all of this is oceanic crust under here, because that is underneath the oceans, and the weight of all the water has made it very dense and very shallow in terms of the size of the crust. It's not very thick crust. Okay, so we need to think about what's actually happening at these plate boundaries. So I'll just remove these scribbles on here. And what is the most interesting bit about this whole topic is that at plate boundaries, there are hazards. So we get volcanic activity, we get earthquakes, and we get tsunamis. So that creates these hazards that we need to be aware of as humans, because they're going to cause us lots of problems. So if you look on this map, I'd like you to write down 2 places where you can see the plates moving towards each other. So have a look at some arrows that look like this. Plates pushing towards each other, and name those 2 plates. So I'll do the first one with you. So 2 plates are moving towards each other. That example that I've drawn there is the Eurasian plate and the Pacific plate. Pause the tape now and you can do the other 2. So plates where they're moving away from each other and moving alongside each other. So have a look for the arrows and see if you can find them on the map. So pause now. Okay, and some answers then, just to check you've got this right. So plates are moving away from each other. There's one there, one there, one there, one there. There's lots. All of the blue arrows moving away from each other. So one you could have had for this one, any of those. So South American plate and African. And then moving alongside each other is anywhere they are these yellow arrows here. So you can see them moving alongside each other. There's another one there as well. So for this one, you could have had Pacific and North American, which is this one here. Which you might have heard of, because that's the San Andreas Fault, where that famous film is made. Not a true story. So it might be a good idea. What would be really great actually is if you could have a print screen or a picture of that tectonic plate map, so that you can put that in your notes and put your examples next to it. So we have different plate boundaries. We talked about 3 of them then. We talked about when the plates are moving away from each other, towards each other, and alongside each other. And this creates these plate boundaries. So at the constructive plate boundary, we've got the plates moving away from each other. Okay, you don't need to make any notes right now. We're going to make some notes in a minute on a sheet, but just listen. So as the plates are moving away from each other, magma is able to push up through the crust, and it's able to construct, that's why it's called a constructive plate boundary, new land as it cools. So the rock here cools and forms new rock. So the magma cools and forms new rock. When we have a destructive plate boundary, the plates are moving towards each other, and this destroys the crust because it sinks down into the magma down here and it melts. So that hard rock is melting into molten rock. And similar thing is happening in a collision boundary. The plates are pushing towards each other, but in this one, the plates are pushing towards each other and push up, creating a chain of mountains here, shown by this red bobbly bit. That's those mountains being pushed up because you've got 2 very buoyant continental plates here. So here we've got a continental plate, and we've got another continental plate. And as they push together, they cannot sink under each other, so they push upwards. In our destructive plate boundary, we have a continental plate here, continental crust, and we have oceanic crust here. And that oceanic crust is able to go sink underneath. It's called subduction, and it sinks underneath the continental plate because it's much denser. At a conservative plate boundary, like the San Andreas Fault, the plates aren't sinking or rising, they're just moving alongside each other. So they don't go up or down, but they push alongside each other, and this can create quite violent earthquakes. So what's happening underneath the surface? At a constructive plate boundary, this one here, we have the convection currents under the surface are moving up and out. And what this does is it makes the plates above it here move outwards. It pulls them outwards and allows that magma to rise up. At a destructive plate boundary, we have the plates pushing towards each other. So this one, you can see plates pushing towards each other. This is because our convection currents are pushing towards each other, and that pulls the plates above towards each other. So that creates our destructive plate boundary. So let's make some notes on these. I've put a link to this sheet in the comments below, and you can just take it as a Word document and you can write all over it, or you can print it out, or you can just screenshot this now and you can write your own notes on it. So you've got 4 different plate boundaries to be reading about and making notes. So what's happening to the 2 plates at each one? How are the plates moving? Are they moving towards each other, away from each other, alongside each other? And then what feature happens here? And by that we mean earthquake, tsunami, volcanic activity, or nothing, if you think that nothing happens there. Okay, and there's some information on the next slide I'll show you to help you fill it in. So you've got some information here, so if you can pause the tape, read through that and fill in your sheet, and then we're going to make sure you've understood everything. So what I'd like you to do, your task, is to read this link as well as the sheet you've just done and make sure you've fully understood all 4 plate boundaries. And I'd like you to turn that into 4 flashcards with explanations and diagrams, one for each of the plate boundary types, to practice writing in your own words and summarising the information. And if you finish all that, as an extension, just for a few minutes, revise, test yourself using your flashcards, or get somebody else to test you, like brother or sister or your mum or dad, and then make up a hand movement that shows each plate boundary. So the plates moving towards each other or away from each other, just as a little memory jog for you. And lastly, quick quiz for you. So last week we did a quick quiz with questions. This one's going to be a definition. So you've got 6 definitions here, 6 keywords here, and I'd like you to write the definition for them all, and then the answers are going to be at the beginning of lesson 3. Thank you.
Thanks for doing that lesson today. Be sure to do the quick quiz with your definitions ready for next week, with next week's video for lesson 3. And please subscribe down below and like the video so that you get notification when the next one comes out. Thanks.